Hello, I am Kati P. Sagun, and today let us try to solve Tutorial 1, Stoichiometry. Let's start with Part A, Mole Concept. Question 1. Calculate the relative formula mass of sodium carbonate with 10 water of hydration. So to start with, 23 times 2, and this one will be for sodium, plus 12 for carbon, plus 16 times 3 for oxygen. Next, we move to the water of hydration. So basically, we just need to multiply 10 to the molar mass of water, and that is 2 plus 16. Is equal to 286 grams. Next, we move to question 2. How many atoms of sulfur are there in 0.25 mole of sulfur atoms? So we are given Avogadro's number 6.02 times 10 to the 23. So we need 0.25 mole of sulfur, and then we will divide this to 1 mole of sulfur, so we can immediately cancel out the unit and then multiply to the Avogadro's number 6.02 times 10 to the 23. So the answer will be 1.05 times 10 to the 23, and we will round it off to 1.5 times 10 to the 23rd power. So that's the number of atoms for sulfur. Next, we move to question 3. How many moles of calcium carbonate are there in 2.5 times 10 to the 24 formula units of calcium carbonate? So let's start with 2.5 times 10 to the 24th power times, we divide it again, 6.02 times 10 to the 23rd power. So we can immediately cancel out the unit, and then this one will be equivalent, multiplied by 1 mole, equivalent to 4.1528 mole, and we can round it off to 4.15 mole. Next question, how many moles of ethanol molecules in 9.25 gram of ethanol? So we have here C2H5OH. We first need to calculate the molecular weight. So 12 times 2, that one will be for carbon. And then we have 5 for hydrogen. So 1 times 5 plus 16 for oxygen plus 1 for hydrogen. So you can get all this information from the periodic table. So adding it up, all up, we can get 46 grams. We were given 9.25 gram of ethanol. So to cancel out the unit, we will divide by 46 gram to get the mole, and that one will be equivalent to 0.20108 mole. Then we can round it off to 0.2 mole. So as you can see, we just need to divide to cancel out the units. Okay, number 5, the compound ethylene glycol has the following analysis. 38.7% of carbon, 9.7% hydrogen, 51.6% of oxygen by weight. Always remember that 38.7% is also equivalent to 38.7 gram per 100 gram. So you can actually just show the same percentage into gram per 100 gram. So letter A, determine the empirical formula of the compound. So we have 38.7 gram of carbon times 12 grams, equivalent for 1 mole of carbon. So we just calculate and it will be 3.225 mole of carbon. Remember, when you add 38.7, 9.7, and 51.6, that is also equivalent to 100. And then down here we have 9.7 gram of hydrogen. You can calculate how much mole is that, and that is 9.7 mole. Then next, let's calculate the mole of oxygen. 51.6 divided by 16 gram. So we have 3.225 mole of oxygen. And so down here, we just need to check which one is the lowest amount, lowest mole. But so far, we have the same values for carbon and oxygen. So we can just use whatever. So I've written here, choose the lowest mole and divide. So 3.225 mole is the lowest value. So 3.225 mole of carbon divided by 3.225 equals 1. Then for hydrogen, 9.7 divided by 3.225, that is equal to 3. And then 3.225 divided by the same number is equal to 1. So therefore, so we have CH3O. That's our empirical formula for ethylene glycol. Then question B. 1 mole of ethylene glycol weighs 62 grams. Write down the actual chemical formula of this compound. So let's go to letter B. We have 62 grams of CH3O. Molecular weight is 31. So we basically just need to calculate. So 62 divided by 31 is equal to 2. So we just multiply everything by 2. Therefore, our answer will be C2H6O2. And that is the chemical formula of ethylene glycol. Then let's move to question 6. When analyzed, a sample of a certain inorganic compound produced 0.01 moles of calcium, 1.2 times 10 to the 22nd power carbon atoms, and 0.64 grams of oxygen. What is the empirical formula of this compound? So, no need to do anything for calcium because it's already in moles. So we just write it down, 0.01 mole. Then next move to carbon. 1.2 times 10 to the 22nd power. that is atoms. So remember the Avogadro's number. We just need to divide this to the Avogadro's number, which is 6.022 times 10 to the 23rd power to get the mole. Can cancel out the units. So that is equal to 0.0199 mole. Then for oxygen, we have 64 grams of oxygen. Sorry, that is supposed to be 0.64 grams as written in question 6. So help to correct that in your notes. And just disregard the 64 there. It's supposed to be 0.64 grams. So divide by 16 grams and it will be equivalent to 0.04 mole of oxygen. And the lowest value here is 0.01. So just need to divide by 0.01, which is the lowest mole value. So for calcium, 0.01 divided by itself equals 1. And then for carbon, 0.0199 divided by 0.01 is equal to 1.99. And then 0.04 divided by 0.01 is equal to 4. Therefore, it is CaC2O4. Then question 7, C2H6 or ethane burns in excess oxygen to form carbon dioxide and water. When 4 moles of ethane is burnt in excess oxygen, question 1, write the balance equation for the reaction. So, we just need to write here C2H6 for ethane, then plus oxygen equals to carbon dioxide plus water. So how do we do this? First, let's look at carbon. Down here we have 2 carbons and then here just 1, so we just need to add the 2 in front of carbon dioxide. And then we have 6 hydrogen, so we have 2 on the right side, so we need to put 3 for it to be equivalent to 6. But right now we have a total of 7 oxygen, 4 plus 3. So on the left side we have oxygen, we need to multiply by 3.5. But then in the end, we need to multiply the whole thing into 2 because we cannot have 3.5 mole oxygen. So 2 C2H6 plus 7 O2 is equal to 4 CO2 plus 6 water. Letter B, calculate the number of moles of oxygen gas. So 4 moles of C2H6 divided by 2 moles of C2H6. Then we have 7 moles of oxygen. Remember, we have 2 moles and to 7. So it's equal to 14 mole of oxygen. 2 C2H6 and 7 O2. And question C, calculate the number of moles of carbon dioxide produced. So we have 4 moles of ethane again. And then how many moles of wait. Let me use a different color. So 4 moles of ethane, then we can divide this by 2 moles of ethane from the balance equation, then multiply to 4 mole of carbon dioxide is equal to 8 mole of carbon dioxide. Then change the color again. How about red? Letter D, calculate the grams of water produced. So we have 4 mole of ethane again, and divide by 2 mole of ethane from the balance equation, and multiply by 6 mole of water. Then divide by mole of water, multiply by molecular weight of water, which is 18 grams. So that will be 216 grams of water. Then let's move to question 8 and part B, concentration molarity. 8. Calculate the molar concentration of the following solutions. Letter A, 4 liters of solution containing 2.8 moles of sodium chloride. So we have 2.8 mole divided by 4 liters. So that's 0.7 molar. Then letter B, a sodium nitrate solution of concentration 880 gram per liter. So 880 gram per liter, you just need to convert. So need to divide by the molecular weight. So 23 plus 14 plus 16 times 3. So this one will be for sodium nitrate. That is equivalent to 85 grams. So we can cancel out the gram unit. And then it will become mole of sodium nitrate already. Cancel, cancel. So mole per liter, it becomes 10.3529 molar or 10.3 molar. Just to round it off. Number 9, what volume of 0.86 molar table sugar solution has 50 grams of sugar dissolved in it? So we have 50 grams, and we will divide it by the molecular weight. So just calculate 12 times 12 plus 22 plus 16 times 11. That is 342 grams. Okay. Twelve times 12 plus 22 plus 16 times 11. Let me just write it down here so that you can easily refer. So we already have mole of table sugar. 0.014619 mole. But we are required to know how much volume is there. So divide by 0.86 mole per liter, and that is the molar mass. Molarity, sorry. So equals to 0.1699 liter or 0.169 liter. Question 10. How many grams of potassium bromide would you get if you evaporated the water from 85.75 ml of 1.27 molar solution? So, molecular weight of potassium is 39.098, and then bromine is 79.904. So remember, mole per liter is equal to molarity. So if we have 85.75 ml divided by 1000 ml, so that we can convert that to liter, that is 0.08575 liter. And then we have 1.27 mole per liter, which is already given. So we just need to write it down, 1.27 mole per liter, and then let's cancel the potassium bromide mole, and then convert that to grams by multiplying by 119.002 grams, which is the molecular weight of KBr. So we can get 12.9617 grams, and let's round it off to get 13 grams. Question 11. Calculate the concentration of a solution made by diluting 400 ml of 1.5 molar sodium carbonate solution to a volume of 1 liter. So here we have 1.5 mole per liter times 400 ml divided by 1000 ml. So we are basically converting 400 ml into its equivalent in liter. Then let's divide by 1 liter. So we can get 0. Erase. 0.60 molar. Okay, let's cancel the liter. So what we have left is mole per liter. Then question 12. 250 ml of a 2 molar sodium nitrate solution was diluted with water until its total volume was 400 ml. So letter A, what is the concentration of this dilute solution? So 2 mole per liter times 250 ml divided by 1000 ml, just to convert 250 ml to a liter. And then let's divide 400 ml by 1000 ml to convert it into liter again. So we can get 1.25 molar. Then change the color for letter B. What volume of the dilute solution contains 1 gram of solute? So we have 1 gram of sodium nitrate. And then we will divide it by the molecular weight of sodium nitrate, or molecular molar mass. So 23 plus 14 plus 16 times 3. That is equal to 85 grams. So we already have mole of sodium nitrate. But we were required to get the volume, remember? So we need to divide this by 1.25 molar, and that was the molarity. Remember, mole divided by molarity is equal to volume. So 9.41 times 10 to the minus 3 liter. But then we need to convert this to ml. So just need to multiply by 1000 ml to get to cancel 1 liter, and that is 9.41 ml. Question 13. Calculate the concentration of a solution made by mixing 50 ml of 0.15 molar potassium hydroxide solution with 75 ml of 0.25 molar potassium hydroxide. Assume the solution volumes are additive. So first, convert 50 ml to its equivalent in liter. and then multiply by 0.15 molar to get the moles. And then let's do the second one, which is 75 over 1000 ml to convert that into its liter equivalent. And then let's multiply to 0.25 mole per liter to cancel out the liter, and then we have mole already. So we just add both. And then divide by, it was stated there that let us assume that the solution volume are additive. So the first one, we have how much? 0.05 liter. Then the other one, 0.075 liter. Okay? Then let's add. It will be equal to 0.125 liter. And then we already have mole and the liter. Let's calculate, and it will be equal to 0.21 molar. So we've already solved all the questions. Thank you so much. And remember, practice makes perfect. Alright. See you in class.